Hello everybody. In today's session, we'll be learning about inductive transducers, in which we'll be looking into the basics of inductive transducers, their principle of working, types of inductive transducers, and some of their real-life applications. So let us move towards our session. We'll be looking about principle of working. So how does an inductive transducer work? They work on the principle of inductance change due to any appreciable change in quantity to be measured, that is the measurement. How can an inductive transducer can be made to work? It can be done by changing the flux with the help of measurement. The change in flux obviously causes change in inductance, and this inductance change can be calibrated in terms of measurement. Let's see about classification of inductive transducers. There are two types of inductive transducers, simple inductance type and two-coil mutual inductance type. Let us first learn about simple inductance transducer. In this type of inductive transducer, a simple single coil is used as transducer. When the mechanical element whose displacement to be measured is moved, it changes the flux generated by the circuit, which changes the inductance of the circuit and corresponding output. The figure here shows a simple coil inductance type. Here the magnetic material is connected to an electric circuit and it is excited by an AC source. At the bottom there is another magnetic material that acts as the armature. As the armature moves, the air gap changes with changes in flux and which changes the inductance generated in the circuit and corresponding output changes. Let's look at two-coil mutual inductance type transducer. In this arrangement, there are two different coils. First coil is where excitation is generated via an external source, and second coil, in the second coil the output is obtained. The output is proportional to the mechanical input. In the figure shown here, A is the excitation coil and B is the output coil. Inductance of B changes due to change in position of armature, which is connected to the mechanical element whose motion to be measured. As armature moves, the air gap changes, resulting in the change in flux generated in the circuit, and thus inductance of the circuit also changes, thus giving us a change in output. Since we have learnt about types of inductive transducers, now let us see what real-life applications they have. Inductive transducers find application in proximity sensors used for position measurement, dynamic motion measurement, touchpads, and so on. That would be all for today. I have taken reference from the book Mechanical Measurement by Thomas G. Beckwith and Louis Buck. Hope you enjoy. If any doubts or clarification, please drop a comment, and if you like, please subscribe and put up a thumbs up button. Thank you.